Layout-based top-down design. In ZW3D 2024, we added a top-down design process based on layout, which is used to achieve stable and fast one-way transmission of model information in top-down design, so it can meet the requirements of parametric product design. In the layout model, we can draw the assembly skeleton with key parameters, and then decompose the skeleton and publish it to other engineers for collaboration. When we modify the skeleton parameters, it can directly transfer changes to the part model to achieve fast modification. Next, we will show you the design process using an example of a vacuum cup. First, insert the new component into the assembly environment. Select the master layout option and draw the skeleton model. In the layout mode, only the corresponding modeling functions are retained, and the reference of other parts is restricted. We can use the equation manager to create key parameter variables. For example, we create the parametric variation and draw the skeleton of cup body. Then use the same steps to complete the other skeleton sketches. Next, publish the skeleton. Click the Publish Set command in the Data Exchange module. Select the skeleton outline to publish. And you can see the Publish Set node displayed in the History feature. Now, let's create the part model and import the skeleton for reference. Select the Copy External Geometry command. Then select the corresponding Publish Set in the skeleton. And design based on the replicated skeleton. Finally, insert the parts created above into the assembly file with a default frame to complete the overall assembly of the product. For top-down design, we need to make changes to the skeleton while ensuring that the reference parts are updated. Now, we modify some dimensions of the skeleton, such as cup body diameter, the distance from the separate cover to the cup bottom. When we return to the assembly file and update it, you can see that the dimensions of the other parts have changed as well. The top-down design process based on layout can ensure the correctness and stability of model information transmission, and greatly improve the efficiency of collaboration in assembly design.